This video I'm just going to do the chapter 3 test from the book just in case you needed some examples to follow when you were studying. So number 1, it's a graph and it looks like there's a bunch of numbers on here, and in between the -6 and -8 is a open circle and with shading to the left, and that is x, or whatever letter is less than -7. I'm going to try to do this pretty quickly because there's a lot of problems and you can just pause to write down the notes or to see what I'm doing here. But remember, watching a video does not take the place of actually doing practice problems and making sure you can do them on your own. So only use this as a guide, but actually do the problems to study. Number 2, again, I'll just let you look at the graph in the book. It's on page 227. Looks like it's in between 4 and 5 and going to the left, so x is going to be less than or equal to 4.5. Number 3, looks like we have an open circle at -5 going to the right, so x is greater than -5. Number 4, we have an open circle in between 1 and 2 going to the right, greater than 1.5. Alright, that's it for the graphing portion, or going from a graph to an inequality. Number 5 says z plus 7 is less than or equal to 9. So we're supposed to solve and graph these. So we're going to subtract 7 from both sides, get z is less than or equal to 2 to graph that. We need a closed circle and we need a shade to the left, less than or equal to 2. For number 6, -1/3 x. I think I did one similar to this in class the other day. For this one, we're going to multiply by the reciprocal. That'll allow us to fruit ninja the fraction away. Don't forget the negative on both sides. So that'll get rid of that, leaving us with the x just like we want. Now keep in mind, when you multiply both sides by a negative, you have to change the direction of the inequality. So you get x is greater than -6. So if that's -6, that's 0, greater than, open circle to the right. Alright, number 7, we've got 5w is greater than or equal to -6w plus 11. So right now there's variables on both sides. We can consider those like terms that we need to combine. We'll need to do that with addition or subtraction. I'm just going to add 6w to both sides. That leaves me with 11w greater than or equal to 11. Dividing both sides by 11 will get us w is greater than or equal to 1. Graphing that, we get a 0, a 1. That's a closed dot and going to the right. Number 8, we have -7/2 times quantity m minus 2 is less than 21. Alright, there's two things we can do here. One of them would be to distribute the -7/2. I'm not going to do that. I'm instead going to go the easier route here, which is multiply both sides by -2/7. Remember to get rid of that fraction here. That'll allow us to fruit ninja this out of there. So we end up with m minus 2, parentheses not necessary anymore. We multiplied by a negative, so we're going to flip that. And 21 divided by 7 is 3 times -2 is -6. Now we can add 2 to both sides and get -4. And to graph that, we've got a 0, we've got a -4, and its m is greater than, so we graph this direction. Alright, let's try number 9. We're getting to some absolute value here. So remember, whatever's in the absolute value symbol, if it's greater than, that means it's above 3, so like 3, 4, 5, but also it could be less than -3, so -3, -4, -5. This is an OR statement. So we have x minus 5 is greater than or equal to 3, or x minus 5 is less than or equal to -3. Make sure to do that OR statement before you start adding 5 to both sides, which is what we're going to do now. You add 5 to both sides, and you get x is greater than 8, greater than or equal to, so that's a closed circle, and less than or equal to 2. There's number 9. Number 10, we have a compound inequality. 9 is less than or equal to 6 minus b, so that's a b, don't get confused with the 6. Okay, so we're going to add, so right now we have a -b, that's okay, we'll deal with that later. I'm going to subtract 6 from both sides, or from all 3 parts. Still leaving us with this -b, don't forget that. So I just subtracted 6 from everything there. Alright, now I don't want -b, I want +b. One way we can do that is multiply everything or divide everything by -1. I'll use division just because it fits nicer. Remember, we're dividing by negative numbers, so that changes the directions of all the inequality symbols. And so I actually would prefer if you wrote it like this, because this is how it would be on a number line. The -6 would be farther to the left. And this one is a closed circle, this one is open, and we shade in between. Alright, number 11. We have 4 plus 3n is greater than or equal to 1, or -5n is greater than 25. Alright, so we're going to do these separately. For the left one, I'm going to subtract 4 and then divide by 3. I don't switch the sign because I only divided by 3, which is a positive number. Here I'm going to divide by -5, so I do switch the sign. And it's an OR statement, so I graph it. So we have -1 and -5. So n is greater than or equal to -1. That means closed circle going to the right. Less than -5, open circle to the left. Alright, let's go to number 12. That's 10k is less than 75. And for minus k is less than or equal to 0. So this is going to be an intersection. So I'm going to divide by 10 on this side, so k is less than 7.5. And I'm going to start by subtracting 4. Then I'm going to multiply or divide by -1. I'll divide again because it can fit easier. So k is greater than or equal to 4 because we had to change the sign because we're multiplying by a negative. So we have a 4 and we have a 7.5, and we're less than 7.5, so that's open going this direction. Greater than or equal to 4, that's closed going to the right, and so it's just the intersection, so we should shade in between there. That's it. Number 13. List the subsets of each set. This could be time consuming. We have a 1, 3, 5, and 7. My braces look a little weird, but oh well. So the subsets, I'm going to do it without braces to save time in this case, but the first subset is 1. We can have a 3, a 5, a 7. We can have a 1, 3. We can have a 1, 5. We can have 1, 7. We can have 3, 5, 3, 7. And we can have 5, 7. We can also have 1, 3, 5, 1, 3, 7. Oh, this is going to be time consuming. So 1, 3, 5, 1, 3, 7. We can do 3, 5, 7. Let's see. We got 1, 3, 5, 1, 3, 7. 3, 5, 7. We can have 1, 3, 5, 7 because every number will also be a subset. We can have the null set, which I will put braces around because to show there's nothing in it. I feel like I'm missing something, but that might be right. Let's see. 3, 5, 7, 1. Oh, 1, 3, 5, 1, 3, 7, 1, 5, 7. I think I missed that one. I think that's it though. All right, let's move on to 14. The subsets of red, blue, and yellow, well, that'll be much easier. So you can have red, blue, yellow, red, blue, red, yellow, blue, yellow, and the null set. Oh, and red, blue, yellow. Alright, so that's it for that. For 15, moving right along. A manufacturer is cutting fabric into rectangles that are 18.55 inches by 36.75 inches. Each rectangle's length and width must be within 5.05 inches of the desired size. Write and solve inequalities to find the acceptable range for the length and the width. Okay, must be within 0.05 inches. Okay, so the length has to be between, so we'll say the length, that's an L, has to be bigger than 18.5 but less than 18.6, and the width has to be greater than 36.7 and less than 36.8. So that looks right. It says write and solve inequalities. Yeah, I think that makes sense. 18.5, 18.6, 36 point. Yeah, all right. So 16. Write a compound inequality that each graph could represent. Okay. So for 16, that looks like an OR statement. So x can be less than or equal to -6, or x can be greater than 2. For number 17, that's an AND statement, so we can do it all in one shot. -3 is a boundary, and the other boundary is 2. For 18, got a multiple choice here. All right. Actually, I'm going to do 18 on the next video because I don't want the video to be too long. So I'll do a part B. Thanks for watching.